So our next lesson, 5.2, is going to be us verifying trigonometric identities, and this is going to kind of feel like an algebraic proof, which is what it is. And I think that's why some kids get frustrated with this, because they know what they're supposed to have at the end of their problem, and then sometimes they kind of fudge the middle of their work or skip over steps and then try to claim that they know what they're doing. The whole point of these questions is that you can show me the steps, how to get from one expression down to another expression, and you can't really skip them. You can't claim like, oh, I did it in my head, because that's the whole point of this question, is that you can prove your math through algebra. So you're technically only allowed to do your work on one side of the identity, and then your job is to get it to look like the other side of the identity at the end. Sometimes if I'm stuck, though, I'll work from both sides of the identity and try to figure out where they match up, and then kind of go back to one side and just make it happen. But, you know, obviously I've been doing this for a while, so maybe I don't have to do as much guessing as you guys do. So let's see a few examples. Who knows? I've screwed up a lot so far today when I was recording lessons. Let's see what else I can mess up. We're going to verify that this is equal to sine squared. So basically you want to take the side that is the most disgusting, and that's the one that you're going to manipulate. So this is the most disgusting side, I think. And this one's already done. But they took that left side and they started trading things out. Secant squared minus 1, they traded for tangent squared. And then they rewrote tangent squared as his sine squared over cosine, and then they wrote secant squared as 1 over cosine squared. And then remember, when you divide by a fraction, you really multiply by the reciprocal of that second fraction. So that's what they have set up here. And then they showed, or they would have shown, that the cosine squared is canceled, leaving you with sine x, which is the same as what we wanted. So Mrs. Hofbauer says something like this, like equals the right-hand side. I don't really care if you do that step. For us, I just need to see your work and then like a little check mark at the end indicating that like you notify me that you're done. I mean, it's clearly done, but you know, I need to know that you know it's done. You know that I know that you know it. I verify this identity. So, oh man, you know, which side to start with? Technically, you can start with either. I think I'm actually going to start with the subtraction side just because that holds more algebraic promise. I know when I subtract two fractions, usually that's a common denominator question. So I'm going to manipulate this side. Secant is 1 over cosine. Cosine is cosine. If you want to say over 1, if it helps you, that's good. So now if you were to get common denominators here, you would have to hit this side by cosine over cosine. And then your numerator now becomes 1 minus cosine times cosine, which is cosine squared, over that common denominator of cosine. But I think to myself, isn't 1 minus cosine squared something? Isn't that sine squared? It is. And then something that kids don't think about too often. Sine squared, instead of writing it like that, I'm going to write it as sine times another sine. Because this is tangent. And then I have this random sine being multiplied by this, now I see a tangent, which is exactly what I wanted it to be. So check, check. I know that's not the most beautiful work, but it's pretty easy to follow from a teaching standpoint. I can see that you traded it. And don't be afraid to like literally show I got common denominators, this is becoming this, and I box in this, or I highlight that. Actually, for me, that's easier for me to follow your logic. If I was truly evil, I would make you write words off to the side, right, to explain all your steps. I don't think we'll do that. Or maybe we will. Who knows? Don't make me angry, guys. I'm going to make you write all your steps. Alright, so I think the right side is clearly the most disgusting side. So let's go with that one. My algebra instincts tell me, I feel like a distribution coming on here, huh? So sine times tangent. And while I'm rewriting, if you don't mind, I'm going to trade tangent out for sine over cosine. Because I think that's the direction I'm going to go here. Sine times cotangent will be sine times cosine over sine. Yeah? Okay. So here's where you have to make a decision. In this fraction, nothing cancels. In this fraction, sine does cancel. So I have to think ahead, and I'm going to have to get common denominators. So I feel like in this case, it would behoove me to cancel the sines, and that way my common denominator would simply be a cosine. So this fraction already has the cosine, but this fraction I would have to multiply by another cosine to get a denominator of cosine. So up here, this fraction becomes sine times sine, which is sine squared, plus cosine times cosine, which is cosine squared. And now I have a common denominator of cosine. And then my favorite Pythagorean identity, sine squared plus cosine squared, is really a 1. So I have 1 over cosine, which is secant. Check. Remember, that's what we wanted, secant. So again, I know it's not the prettiest work on the planet, but it's really easy for my teacher to follow, and that's what your goal has to be. So clearly the left side here is the most promising side as far as algebra trades and trig trades. Let's trade everybody out for their sine and cosine buddies. So this cosine is going to stay as it is, but tangent is going to become sine over cosine. Cosecant is 1 over sine. And then cosine stays as it is. And we have one lovely fraction. So one big fraction bar, anything that's in the numerator and the denominator, that term can cancel. So, oh my goodness. Like the world's easiest trig identity. Everything canceled. So 1 equals 1. You do have to show me that, though. Like, you can't just assume I know what you're talking about through the mystical connection that is your teacher and student. No, I have no idea what you're thinking, guys. You got to write it down. All right, clearly the left side has more promise. So let's look at the left side. I think this would be a good candidate for well, there's a couple different ideas. We could do the conjugate, which cotangent squared minus tangent squared. I don't really think that's a Pythagorean. We gotta triple check because I forget that one. No, let's not do the conjugate thing. That's not gonna help me any. I'm gonna look at this denominator and I'm gonna trade them out for their fractions. And I'm gonna leave the numerator as cosecant for a moment. I might trade it in a second. Oh boy, excuse me. Okay, excuse me again. Cotangent is, hello, cosine over sine. Okay, I lost some knowledge after I sneezed. And then tangent is sine over cosine. So it doesn't really help me to have addition of two fractions when they're not together. So what if I was to multiply this fraction by cosine and this fraction by sine? And then I could call this cosine squared plus sine. Oh yeah, I think we're on the right track here, guys. So I have cosecant x being divided by cosine squared plus sine squared over cosine sine. Alright. This is a 1. Right? So instead of dividing by the fraction, I should be putting equal signs here. Let's call this, and I'm going to go ahead and trade cosecant out now for 1 over sine. Instead of dividing by 1 over cosine sine, let's multiply by cosine sine over 1. Aha, I think we're there. Sines are gone, and I end up with cosine, which is what I wanted. Hot dog, that was super fun. Okay. Oh my goodness. Yuck. Alright, even though I don't want to look at it, the left side is most definitely the most disgusting side. We don't have common denominators, that is clear. The good news is, I think when I get the common denominator, it's going to be a nice factoring pattern, so that's cool. Alright, so here, let's multiply by sine y plus 1. Numerator and denominator though, right? Because that's how fractions work. So over here, we'd have to multiply by the sine y minus 1. I'm going to be lazy and not write it all out because I got class starting in a few minutes. So this fraction's numerator becomes 1 times sine y plus 1. So I'll just write down sine y plus 1. And this is where usually kids would mess up. We have a negative 1 that we're distributing into sine y minus 1. So that's a minus sine y. And then negative 1 times negative 1 is going to be another plus 1. So watch that distribution of the subtraction. My denominator, however, is, we can leave it as sine y plus 1, sine y minus 1. Or if we were to FOIL those together, distribute those together, you would get sine squared y minus 1. And I like that because I think we can trade that in a minute. Alright, let's look up here. Ooh, sines cancel. 1 plus 1, that's 2. So we have 2 over, guys, this is something. This is a rearrangement of the original Pythagorean identity, but it's one where like they subtract things from both sides. And when you rearrange that very first Pythagorean identity, you know, the cosine plus sine equals 1. Gosh, helps if you can read my writing. If you were to keep the sign where it's at, but subtract 1 and then subtract cosine, you get negative cosine over here squared. So that's what we have here. We have negative cosine squared x in the denominator. And then think about where I'm trying to go here, guys. They want it to be secant. Well, guess what? That is secant. Dividing by cosine is secant. So we have negative 2 times the secant squared of x. Check. Alright, that was kind of an awful one. Sorry. Oh my goodness. You know, it's kind of a coin toss as far as like which side is the ugliest. They're both pretty darn ugly. I think I'm gonna, this is a cubic pattern. This is the difference of 2 cubes pattern. So I'm gonna use my space over here just to show you something. This is the pattern from algebra factoring, that when you have the cubic difference, it factors into a minus b times a squared plus ab plus b squared. I think that's the key to this problem. So a and b are sine x and cosine x. So filling out that pattern, it would be sine minus cosine times sine squared plus sine times cosine plus cosine squared. Okay. I overestimated my space, or underestimated my space. Keep this, because I notice, voila, that's there. Ooh, I think we're done. Look at this. Sine squared plus cosine squared. Isn't that just a 1? So look what I need here, guys. 1 plus sine cosine. I think we're done. I wouldn't feel real good if this was a test question and this is how I left it, so I'm probably going to rewrite it as, I don't know, I could really impress my teacher by saying sine squared x plus cosine squared x plus sine cosine times sine minus cosine. And then I'll make a little note so my teacher understands that I realize that's a 1. So I think we're done now. 1 plus sine, x cosine x times sine, it's a minus, sine of x minus cosine of x, which is what I wanted. So the note to use the cubic factoring pattern, like, it's pretty awesome. Alright, so I won't say you'll run into that one too often, but that was neat. I liked that. Maybe it wasn't the best way to do the question, but it's how I did it. Alright, number 7. I think the left side has the most promise when I look at number 7. Methinks. So let's look at using, you know what, let's trade tangent. Tangent is sine over cosine. And then if I'm trying to add these two fractions together, I think if we go ahead and try to get common denominators, that'll be fine. Because look, I'm going to multiply this guy by the 1 plus sine. Numerator and denominator, of course. I'm going to multiply this guy by a cosine. I'm cheating a little bit, sorry. So this blue part here times sine will end up being sine plus sine squared plus, and then this red part will be cosine squared, of course. Oh, I already see something awesome that's about to happen. My denominator is the common denominator of cosine times 1 plus sine. Alright, look at this. This guy. That's a 1. Yeah? So we have 1 plus sine up in the numerator over cosine times 1 plus sine. And then the factor of 1 plus sine is common to the numerator and the denominator, so you have 1 over cosine. Ladies and gentlemen, that is secant. Check. That's what I want. Alright. Ooh, Good times. All right. I'm going to skip this one just because it's like really similar to the one we just did. So get common denominators, trade out some stuff. You're going to like it. All right. The next section, it talks about identifying identities and non-identities and using your graphic calculator to test whether it's even an identity to begin with. So they want us to type these into a calculator. One side of the equation into y1, one into y2. So if you type this into y1, remember cosecant is a reciprocal of sine, so I would type 1 over sine x minus sine x. And then in y2, whoop, you're going to type that. So you're going to type cotangent will be 1 over tan x times cosine x. And notice I didn't even bother simplifying those because my calculator doesn't need me to. If you type that into your calculator and then you look at the graph, and you look at them together, you would see that they're graphing the same function. Like I have a color screen calculator, so it's really easy to tell when the blue and the red like overlap. On the grayscale ones, it's a little difficult. But just testing it out on my calculator, yeah, they are the same function, technically, when I go to graph it, which means these are identities, but that's not enough of a verification. So now if my teacher says, now you got to go back and verify it, you got to go back and verify it. So we pick a side to work with. I'm thinking I'm going to work with the left side here. This is 1 over sine. So this is one of those get your common denominators questions. So I'm going to multiply the second fraction here by another sign. So my numerator becomes 1 minus sine squared over sine. And then remember 1 minus sine squared, that's that Pythagorean identity kind of reorganized. So that's cosine squared over sine. And then, this is that weird one where you have to remember cosine squared just means 2 cosines multiplied next to each other. So if you kind of peel them away from each other, you can use them as separate fractions, right? So if I give the over sine part to just one of those cosines, this is cotangent. And then I leave the cosine, that was the extra cosine, off to the side, which is what I wanted. Check, check. All right. So I guess the moral of the story is don't waste your time trying to verify the identity if it's not even an identity. Like for instance on this one, oh, there's already ink on it. Meh. The illusion is lost. Okay, this one. If you try typing this one, oh, we did 9. Number 10? Number 10. Oh, yes. If you type this into y1 and y2, so one side into y1, one side into y2, turns out they're not even the same function. So there's no point in us verifying the identity when they're not identities. Okay. All right, that's our lesson on verifying identities. Think about all the algebraic manipulation techniques we used, and just remember there's not just one way to verify an identity. You know, my work might take 5 steps, and you found a shortcut and only took 3 steps. As long as those steps aren't just you skipping steps, that's okay. Good luck.